Today we are going to discuss and solve problem number 10 from NeetCode 150, which is valid palindrome. Let's jump into the problem. So this is our agenda. Understand the problem statement, walk through the examples, brute force approach, discuss time and space complexity, optimal approach, discuss time and space complexity. Let's understand the problem. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. Constraints: S dot length varies from 1 to 2 into 10 power 5. S consists only of printable Ascii characters. Okay, let's walk through the examples. So this is the example 1. So this example: a man, a plan, a canal, PA and a Panama something. Okay, so as per the problem statement, we will be converting all the uppercase letters into lowercase letter. If you see, this capital A is converted to small a, and this capital P is also converted into small p, and we are removing all alphanumeric characters, means this space, this comma and this colon, right? All the spaces and this colon, and then all the commas. So we will be getting this particular string. If you reverse the string, you will get the same string. That's why the output for this particular input is true. Output here is true. If you see in this example, the first, this is 0 capital P. So this is not O, it's 0. Okay, so I'll be converting this uppercase P into smaller case p. If I reverse this, I'll be getting something like this. This is not the palindrome, right? That's why the output for this input is false. This is example 3. Raise a car. Here we are having only spaces. We will be removing that thing. We will be getting something like this. And if we reverse this particular string, we will be getting this. This is not the palindrome, right? After we reverse this string, we are not getting this exact string. That's why it's not a palindrome. So that's why palindrome means we will be getting this, we will be getting the same string after reversing the particular string. So that's why the output for this is false. Here only we are having one empty space. We will be removing that thing. So we will be getting empty string. So if I reverse that empty string, I'll be getting the same thing. That's why the output for this is true. Clear? Okay, so these examples are clear. So somehow we will need to do the process in which we will be removing all alphanumeric characters and we will be converting all uppercase into lowercase letters. After that, we will be having one final string, right? We will need to check if that particular final string is equal to the reversed form of that final string or not. If yes, we will need to return true, else we'll need to return false. Okay, basically we will need to iterate the given string, right? That's the main thing we will be doing. So let's code this thing. That's the brute force approach. We will need to iterate the given input string, and we will need to check each and individual character, whether that character is a small case, we will continue. If it is a uppercase, then we will need to convert it into lowercase. If it is a non-alphanumeric character, then we will need to ignore that thing, right? So this is the process we should follow. So let's code this thing. Int n is equal to s dot length. So for int I is equal to 0, I is less than n, I plus plus. So what I'm going to do, I'm going to create one variable which is Ascii variable. So Ascii equal to s dot char at of I, right? So before that uppercase alphabets Ascii value, where is 6 is it? Yeah, 65. Similarly, lowercase, it is 97. Lowercase. And numbers, Ascii value is starts from 48. 48 to 56. 57. Here it will be plus 26, exclusive of the 26th one. So it will be 90. Here it will be 26. It will be 122. Right? So this we should know. We need to somehow memorize or know this thing. 65 is the starting Ascii of the uppercase alphabets. 97 is the starting Ascii value of the lowercase alphabets. And for numbers, the value starts from 48. Then we don't need to memorize the two value. We will simply add 26, and we'll simply here we'll be simply adding 9. Okay, fine. So let's code this thing. If suppose this Ascii value is greater than or equal to 90, if it is less than or if it is greater than or equal to 65, and Ascii value is less than or equal to 90, in that case what we will need to do? So let's also create one string builder. Let's call it as final string, which is equal to new string builder. What we are going to do, character converted character is equal to character Ascii plus 32. Means, let's say if the current character is, let's say C, in that case Ascii value will be what? 67, right? So 67 plus 32, capital C, sorry, not small c, capital T. 32 gives me 99. So 99 is the Ascii value of small c. So converted character we will be getting small c in that case. So we will be adding this converted character into our final string. Converted character. Okay. Else if Ascii value is greater than or equal to 97 and Ascii value is less than or equal to 122, in that case we will be adding this current string into our answer, sorry, final string. Yes, dot char at of I. Another thing is we will also do the same if we encounter numbers. That's why I'm going to add our character or condition. Ascii value is greater than or equal to 48 and Ascii value is less than or equal to 57, then also we will be doing the same thing. Else we will not append the current character. That's it. Finally, what we are going to do, return final string dot toString dot equals of final string dot reverse of dot toString. Let me run this code now. I hope this is clear. What I written is, if this is true, this means this is the uppercase. Current character is uppercase. That's why we are doing this, converting uppercase into lowercase, and we are adding this converted character, adding converted character into final string, right? If not, and also if it is a valid thing, if it is a alpha number and alphabets is lowercase, then we will be simply appending the current character into the final string. and we are checking if that string is equal to the reversed form of the same string, then we will be returning true. So this logic is correct. Let's run this code. Sorry for the network interruption. This should run successfully. Let's see. So we should. Really sorry for this delay. Okay, let me submit this. Hope this should be submitted successfully. Yes. Let's discuss the time complexity. Time complexity is order of n, and space complexity is also order of n, where n is the length of the input string. This is the worst case thing. Worst case time complexity is big O of n, and space complexity is big O of n, where n is the length of the input string. So yeah, this is the brute and optimal approach for this problem. I don't think so we could. This is the optimal way, and this is also the brute force, right? So this is, yeah, that's it. Thank you so much for watching.